Hi everybody. In this video, I'd like to talk about how to store passwords in a database and how to use passwords, what's the mechanism we use to log people into our website. And the reason we're worried about this is we're worried about data breaches, that someone might hack into our database, our database server, and grab a lot of stuff. I've just typed in, passwords stolen in 2017, and you see that things are kind of happen quite frequently that passwords get stolen. Here's another article about all sorts of sites that got stolen. Here's one in particular, and one reason why I asked you when you're just learning how to use Postgres and creating passwords that you start by actually creating good passwords. Because here this hack was because there was the default password on the router was 8 lowercase letters from the alphabet. So that's really not a good password to use, and that led to 800,000 people having to reset their password. Foodie.com, stolen email addresses and passwords, and this entire list from Wikipedia, list of data breaches, is pretty severe. So what can we do to prevent this, or what can we do if there is a breach that it's not as big of a deal as it could be? How to minimize the problem? So here I have some just kind of a layout of what things might look like. Here's my site, z.org, and I have a table, let's say, in a database with a username and password. And I'm just storing passwords, and as they call it, in the clear, meaning that when a person's password is the word password, I store that word password. So Anne's password is password, Ben's XYZ123, Clara is password, and here, let's say Capital One has a similar table in their database with username and password. Now you can see the problem right away, that if there is a data breach and this table information gets out, and let's say Capital One gets out and they have hundreds of thousands of users, all of a sudden everyone knows the password. So this is not a good way to do it. But before I get started in what's bad about this, let's see how we would use it. So if a user logs in, Anne is trying to log in, and they type their password, we can just do a simple select statement, right? Select splat from users where username equals Anne. So that would be what the person typed in, and password equals password. So here, and these again are what the user's typing in. If we find a match, we know that they typed their password correctly, and if we didn't find a match, we know that they were incorrect in their password, as I showed in the previous video. So this is a fairly easy method to use, but it's super, super insecure. So let's try to think of other possible solutions. Well, one solution is to what's called hash a password. So we're going to have a mathematical formula that will convert a string of characters into some other string of characters, and we can't go back. The cost of going backwards from this arbitrary string of characters back to the original password is much more costly than going from the word password to that string of characters. And one algorithm we can use is this MD5 one, and if I type the word password here, we get the string of characters that is its hash. So we have a function that goes from from text into a string of bytes. This is called hashing, and it works in one direction. If I know this, I cannot go back and determine what the password is. So let me just show you what that would be like. Well, let me make sure I copy this. So instead of this approach, let's call this the original password. And then what I'm really going to store is the hash of the password. So I'm not going to store this column. I'll store the username and that hash. So let me get that. So I would store that. That's the same. Let me just kind of fill these in. Give me a second. And let me find XYZ123. I think I didn't screw up. can just say this is the hash. So again, I'm not going to store the password. I'm going to store the hash of the password. And if someone steals this, it's difficult to go back in the other direction and decipher the password. And how I'd use this, instead of when a user types in a password, I'm going to hash this password before I send. This isn't correct syntax, but it's kind of the idea. So I'll hash this string the person put in and see if it matches this string. So the benefit is, there's a number of benefits. One is that it's a one-way thing, that it's difficult to go backwards, which is a good thing. The one detriment, I guess, is if a person says, I forgot my password, what is it? We can't tell them. And as you know, a lot of sites, or hopefully all the good sites, would never be able to tell you your password. They could just say, well, here's how to change your password. Dishonest, even if an employee had this file, they wouldn't know any of the passwords. If we have a dishonest employee who steals this, or if there's a data breach, you can't really go from this hash back to what the password is. So if our site's hacked, not that big of a deal. Or it used to be not that big of a deal. So the one problem is that hackers have found a way around this system, and it's called rainbow tables. So people ahead of time can run this algorithm, this hashing algorithm, on a huge number of words. Let's say all passwords that are long, are all word letter combinations shorter than 12 characters, and figure out what the hash is. So they can create a dictionary ahead of time. These are called rainbow tables, and we can look at them here. A lot of people publish in this place, projectrainbowcrack.com. We can download these pre-computed hashes. So if the data breach occurs, let me get back to my site here, we can look up 5F4DCC in this rainbow table and see that the original password, or the real password, is password. So this is a big problem, that hackers can just have these tables of pre-computed hashes ahead of time and get around our site. So then people came up with the idea of, let's add something unique to the end of each person's password, and let's call that a salt. Salt is just something added, some string of bytes, or think characters added to a password, and then we'll hash it. So let me kind of show you what that would look like. And the first idea is to just uniformly add something like, let's say my site, I'm going to add CS350 to that, and just give me a second while I get this looking nicely. And let's say capital 1 uses the salt. Big bucks. Let me line it up a little bit here. All right, so now when we are hashing a password, we first add the string CS350 to the original password. So this would be password CS350, and then we'll hash it. So let's take a look what that would be like. So instead of password, I'm going to do password CS350. Now, whoops, I didn't do the right one. I wanted to do this one. And this is the same, password CS350. And now let me do XYZ123. And this is different than my site. This is password big bucks. So let me go ahead and do that one. That's this password. Oops, I didn't finish. So there. So now I've added this salt to the password. My salt in my site is CS350. The salt for capital 1 is big bucks. And when I hash it, they're different. So even though Anne's password is the string password, on my site it's a different hash than on capital 1 site. So this sort of defeats the purpose or the use of rainbow tables. No longer can people pre-compute these hashes. So it makes it much more difficult to use. So the algorithm would be that before we do this select and match, so we take someone's password in, we add the salt to that password, I guess just plus salt, we hash it, and then see if that hash equals what we've stored in the database. So that's that idea. Now here's one problem with this approach, is that suppose Anne is hacked. Either, let's say someone calls her up and they say, hi, we're from tech support in z.org, and they're not really, they're just a hacker somewhere. And we need to decipher what's wrong with can you give us your password? And she gives the password. Well, now not only is her account hacked, but that person now knows that the original password was password and the hash is this. So any hash that matches also has that same password. So not only is Anne's account breached, but anyone whose password is the same as Anne's is breached. And the reason is they're the same hash. We've been using the same salt in our system. So then people came up with the idea is, let's generate random salts. And I should make mention that even though I'm making salts very short here, just a few letters, that these salts are much longer than these. But let me keep with my short character example. But we're going to randomize salt. So this one's A2P9, and this one's XU0E, and this one is whatever, KKLP. So we just randomly are selecting salts, and the same thing down here. And now it's going to be password A2P2, and even though Clara shares the password, we're going to hash password KKLP. So let me I'm never going to remember this, so I'm just going to copy it. So that person's password, Anne's password, is this one. And let me do Clara's password here just to show you that they are going to be different. And the thing you're probably hopefully seeing also is that even though these hashes share a lot of the same letters, this one's password KKLP and this is password A2P9, they don't look anything alike. So you can't really see that, oh, most of the letters are the same in these two, that these hash functions are really good with that. So that solves this problem of that even though Anne's password is, someone finds out Anne's original password here, again, the only thing we're storing in the database so far is this username and hash. So even though someone finds out Anne's password, it's not helping them decipher anyone else's password in the system. So this is kind of the best method we can come up with, is that we're going to have randomized salts. So now Anne comes, this is her password here, it's password, and we've created a random salt. Now we want to check, Anne wants to log in. So she gives her username, Anne, and she gives her password. And so here we're needing to add salt to the password. But I just said we need, these are going to be random, and we have to keep track of what that random one is in order to add it back. So if we want to check whether the person can log in, we need to know this salt. Right? If they're always randomly generated, we'd never know if the person gave the word, if the person typed in password the next time and we randomized the new salt to be KKLP, that's a different match. That won't match. So what we have to do in order to make sure these hashes match is always add, even though for each person the salt is randomized, when that person logs in again, we want to add in that same salt. I tried to say this a number of ways now. I hope it's kind of clear. So what we're going to do, and the interesting thing is, even if we make the salt public, it's not going to affect the security of our system. So even if we say, hey, Anne's salt is A2P9, it's not going to help people decipher what this hash is, nor will it help person with Clara's thing. So we're going to append that to the end of each of our well, let's say we're going to append it to the end of each of our hashes. And the program will know that the last few bits are going to be the salt. We add that to the password, and then we're going to see if it matches this hash. So that's the basic idea of what we're trying to do. So now I've shown you storing passwords in the clear, a super bad idea. Hashing passwords using perhaps something like MD5. That's better than storing passwords in the clear, but we can use a rainbow table to get all those passwords out. Or if we were hackers, we could do that. Then the next step is we could set a salt. We could salt the algorithm. So that simply means we're adding some text string to the original password before we hash it. And then random salts are even better. We are randomizing which salt we use. Instead of CS350 for everyone gets a new random salt that we're attaching it to, and that prevents us from, even though Anne releases her password and says mine is password, Claire's account is not vulnerable in that case. So with all that in mind, we can look at and so now I typed in my name and tried to see if I've been hacked anywhere, or if sites that I have accounts in have been hacked. And yes, they have. So Dropbox has hacked, and we see that it salted hashes of passwords. So we don't know too much if they're random salts or not, but half of them were in bcrypt, and that's an actual algorithm I'm going to show you how to use. So I'm pretty confident that my password hasn't been released there. Here we get to the Tumblr exploit in 2013. That, they say, was a salted SHA-1. That's the algorithm they're using, but it's salted, and now we know what that means. So that's okay. We don't know what kind of salting they used, but that's better than just SHA-1 by itself. This one looks like I'm not exactly sure, but it may be that passwords, oh no, this one just released passwords and had the actual passwords in plain text. This one, the GitHub accounts were leaked. Last.fm, this is the worst one. It was stored as unsalted MD5 hashes, and as now we know, unsalted means that people can just use those tables, list of rainbow tables here, get the ones for MD5 right here, go look up my account, and if I have a relatively short password, they're going to know what my password is. Here, the LinkedIn site, they were stored in SHA-1 hashes without salt. So that's, and it says the vast majority of which were quickly cracked in the days following the release. We know that is quick because with unsalted hashes, people can just use a rainbow table. And here, SHA-1 hashes, this was unsalted again. So we see, now I'm hoping you see, well, what these terms mean, first off, when you see them in the press. And secondly, the best option is to use randomized salts before you hash. And that's the way I'm going to show you to do this. There are many ways to do it, so you don't need to use this method, but be aware that the general idea that you want to have random salts and then hash your passwords before you store them in the database is the way to go. And other ways, like storing passwords in the clear, is probably the best, fastest way you can go and lose your job at some company. You don't want to be responsible for leaking all these passwords. Okay, so in the next video, we'll just be doing a screencast of coding to see how to do the algorithm we're going to use is bcrypt. How we can hash passwords using JavaScript and save them successfully in a database, and then how, when someone's trying to log in, they can, we can compare that login information with these hashed passwords.